Hello students, in this video I am going to explain assembler design options which is a last but one topic of module 1 of SCD. In this topic we are going to discuss about two alternate design methods of assembler. They are called as one pass assembler and multi-pass assembler. In one pass assembler, the assembler performs a single pass over the source program, whereas in multi-pass it can perform multiple passes. Starting with the one pass assembler, here we have two types of one pass assembler. In the first type, the assembler produces the object code and it is directly loaded into the memory. No secondary memory is involved here, and once directly it is loaded into the memory, then it is given for the execution. Okay, so that is this first method of assembler, we call it as a load and go assembler. The another type, it produces the object program. As in the case of two pass, it generates the object program but performs only one pass over the source program. So we will start with the load and go assembler. Before this, both these two types of both these two types of one pass assembler makes use of the source program, where the symbols are defined in the beginning. You can see here the symbols are defined in the beginning, but in the previous video we have seen the source program where the symbol defining statements we used to write at the end. That is after the executable statements we used to write, but here small modification is done where the symbol defining statements we will write at the beginning. Why it is done? This is used to reduce the problem of forward references, but still you can have a problem of forward reference. You can see here in this program JEQL1, that is jump on equal to statement with the symbol L1. L1 is a forward reference. Why it is a forward reference? Because it is defined in the next statement. Okay, that is after this line it is defined here. So L1 is a forward reference. Now how such forward references are handled by one pass assembler? So starting with the load and go assembler, as I said, it generates the object code which is stored in memory for immediate execution. No object program is generated and no loader is needed, and it avoids writing the object program to the secondary memory and reading it back, and it also avoids performing additional passes over the source program. So how this load and go assembler performs this operation of assembling. Okay, so we will consider with an example first. Here if I consider the same program, as usual it starts assigning this addresses, that is depending on what value we have used with the start. The starting with that, it keeps on assigning these addresses, and at the same time it also constructs the symbol table. Okay, so you can now see that this is the symbol table. Okay, let me start with this first line, start 1000. So 1000 is assigned to here, and we have the symbol G, so it will be entered along with the location counter value 1000. So value of G is 1000. So that is the meaning. And here word means reserve one word and store 20 into that. That is, it's a hexadecimal. So that is what we have an object code here. Similarly, in the next line, we have a value of location counter as 1003, and we have symbol J and entry is made and object code is generated. Here also again 10 with the 1006, no object code because it is RESW. Continuing with the next line, first is entered with the 1009, and this is the object code, And you remember that this is the program that I have taken as a SIC program, and in SIC program all the statements are assembled using 3 bytes. Okay, so LDA is replaced with 00, and G is replaced with its address. Okay, so now say as and when these object codes are generated, it will be stored in the memory for the execution. Okay, continuing with this compare 10. So 10 will be replaced by 1006, and comparison instruction will be replaced by 28. Okay, continuing with the next line, that is at the 100F we have JEQ L1. JEQ can be replaced by its opcode, but L1 at this point, this one pass assembler doesn't know what is the value of L1, because L1 is nowhere defined before this. So it is a forward reference. So since the assembler doesn't know what is the address of L1, it makes an entry into the symbol table and puts a star indicating that it is undefined, and in the object code it leaves blank, and in the symbol table it maintains a forward reference list. We say a linked list called as a forward reference list, holding the address. Here the address is 1010. Why 1010? See, the this opcode 30 is stored at 100F. The next location, actually it should contain the address of L1. The next location address is what? It is 1010. 100F you add with 1. So that will be the address of this next byte, 1010. So the address where this reference is made, that is stored in this forward reference list. Okay, so and it cannot generate the object code, it leaves it blank. Okay, continues with the next line as usual, and again it continues here in this line, and it finds that there is a L is defined here, and it makes a change in the symbol table entry. You can see in the symbol table it changes this undefined indication to this 1015. You can see here 1015. L1 is now changed with a 1015, and it makes use of this forward reference list 1010. So the assembler, okay, it makes changes in location 1010 with 1015. Okay, so you can see that here this is what is done. The assembler changes this blank. Okay, it fills this blank with 1015. What is 1015? It is the address of 1015. This is how it handles the forward references. And after generating this machine codes for all the instructions, and it checks what is the starting address, what is the address of the first executable instruction, and in this case is 1009, it's 1009, and at this point the execution begins. So this is how the forward references are handled by this load and go assembler. We have one more one pass assembler where it generates the object program. I'll consider the same example, same program, and here as I told, this is the one pass assembler that generates the object program. What are the different records of a object program? We have discussed that in the object program we have a header record, text record, end record. The same thing we have here, that is generated by this one pass assembler. So as usual, it starts with the first statement, and it also constructs this symbol table. As and when symbols are found, the entries are made along with the location counter values. and the if a machine code is needed, that will also be generated, and at the same time these machine codes are stored in the text record, because in the same pass itself it has to generate the object program. Okay, when it finds this start, it generates this header record, and when it finds this next line, it generates this text record. That this text record, first text record, will contain the object codes, first two object codes. That's what I have considered here, first two object codes in this text record. Now no more symbol defining statements. Then it starts with the executable statement, and for the executable statement it generates separate text record. Okay, so LDAG will be converted into this object code, and it will be placed into the text record, and comp10 is converted into the object code, and it will be placed into the text record. Similarly, for this JEQL1, okay, when it comes to this line, as I had told, this is a forward reference. So when it finds this forward reference, okay, so in the symbol table, same way as it was handled in the earlier case, it points that it notes that this is undefined by putting a star, and it creates a forward reference list containing the address where this forward reference is made, and in the object code it puts zeros. In the earlier case it was left blank, but here now it is filled with the zeros, and the same thing is also written into the text record. You can see text record, and it proceeds with the next line, STAJ. STAJ uh, STAJ is converted into the object code, placed into the text record, comes to the next line, and now it finds that there is a definition for L1. So at this point it makes changes. What changes? Okay, so this uses the forward reference list. This one, it uses this forward reference list, and it produces one extra text record, and it indicates that the value of L1 is 1015. Value of L1 is 1015, and that is placed in the text record. Okay, and it also places this address 1010. What is 1010? It is the location where this forward reference is made. So depending on number of nodes in this forward reference list, it produces these extra text records. If one more line has made use of this L1, it will produce one more text record, indicating that the L1 address is 1015, and what is the address where the forward reference is made. Okay, so this is how it produces extra text record whenever it finds the definition of a forward reference, and this is how what is the extra text record that is generated, and it continues as usual with that is a text record containing the object code of this STAG, and when it finds end first, it generates this end record, and then it is given for the loader, and loader, what that loader does, it loads these object codes that are found in this text records in the memory, and in this case the starting address is 1000. Okay, and when it finds this additional text record, okay, it goes to the location 1010. It goes to the location 1010 in a main memory, and replaces this zeros with 1015. Actually 000 should be replaced with what? Address of L1. What is the address of L1? 1015, and that replacing is done by loader using this text record. that is generated by one pass assembler. Okay, so these are the types of one pass assembler. In first, that is a load and go, where no object program is generated, and in the second, object program is generated. And these are the different ways of handling the forward references. Now we will be considering about multipass assemblers. Okay, so before discussing about this multipass, let me consider few example statements. You consider this statement, we call this as a symbol defining statement that we have discussed in the previous video. The meaning of this statement is x1 is a symbol whose value should be equated to 100. That is what it means. And no memory space is allocated for x1. Only it will be entered into the symbol table. Into the symbol table, x1 is entered with a value 100, but no memory space. Okay, now you come to this sequence. x1 resw50. What is the meaning of this? x1 is a symbol that is reserved with these many words, 50 words, and x1 will be assigned some address, say for example 1000. So value of x1 is 1000. Okay, come to the next line. x2 EQU x1. What is the meaning of this? x2 is assigned with the value of x1. Value of x1 is 1000. So x2 value is 1000. So that is what the meaning. Now you come to this one more set of instruction. I have reversed the previous two statements. Okay, these two statements reversed. x2 EQU x1. Okay, here the meaning is x2 should be assigned with the value of x1, but at this line we don't know what is the value of x1, because x1 is a forward reference which is defined later in the program. So here we have forward reference in EQU, and such forward references are not allowed for two pass assembler. That is the restriction with the two pass assembler, that forward references are not allowed for this EQU. So in order to overcome this restriction, we use this multipass assembler. What this multipass assembler does, that is, it's a variation of two pass. As usual, starts with the pass 1, performs all this assigning those locations and all, location values and all, and whenever it finds such type of forward references in EQU, okay, then multiple passes are carried out over such a EQU statement, and once all these forward references are resolved, the output is given to the pass 2. Okay, that means complete source program is not processed multiple times. Okay, complete program is processed only 2 times, but only the EQU statements containing forward reference, they are performed by multiple passes. They are processed with multiple passes. So that is what multipass. So it is not necessary that assembler make more than 2 passes over the entire program. Instead, only the portions of the program, okay, only the portions of the program that involve forward references in symbol definitions. Okay, only those portions the multiple passes are carried out, and this process is followed by normal pass 2. Okay, with one example, I have considered sequence of statement. Okay, these statements, and here I have forward references. Okay, here max is a forward reference. because it's defined later. Again, C and B are forward references because they are defined later. So totally 3 forward references are there, and after resolving these forward references, then only value can be assigned to H, value can be assigned to max. So how to assign? So multiple passes are carried out over these statements. Okay, now we will trace how these values are computed during the multipass, that is multiple passes over these statements. And while solving this problem, you will be given location counter value for some of those statements, some of those symbols. Here in this case, at this statement, value of B is given 1033. That is the nothing but location counter value at this line, that is the value of B. Okay, so such type of problems you can expect in the exam also. So where you will be given some statements, symbol defining statements, and you will be provided with a value of one of the symbol, and you will be asked to trace the result of a multipass assembler. I have started with one simple example. Okay, now how it starts. Okay, and here we make use of certain notations. That is, in the symbol table certain entries are made. Okay, we can have like ampersand 1. Ampersand 1 means number of undefined symbols, and here we also enter the expression, we call it as defining expression. We also maintain a list, linked list, and that is called as a depending list. And star indicates a undefined symbol. Such notations we will be using while considering this multipass assembler. Okay, start with this example. Start with this first HEQU max plus 2. Okay, so when it finds H is entered into the, this is symbol table, this is symbol table, whatever the diagram it is written, it is symbol table. And when HEQU is found, H is entered, and since it is an expression, it has to be computed, and that expression has a forward reference. So all those are maintained here in the symbol table by entering ampersand 1. Ampersand 1 means one undefined symbol, that is a max, and this expression is also stored in the symbol table. And a null pointer, I'll tell you what is this null pointer later. Okay, that is one linked list will also be maintained. For the time being, there is no linked list for this first entry. Okay, at the same time, one more entry is made. What is the forward reference in this case? That is a max. So that is also entered into the symbol table, and indicates that it is undefined, and one depending list is maintained, indicating that H H requires max. Okay, and null pointer. Okay, so this is done when process the first line. Okay, continuing with the next line, max EQU C minus B. So when this is found, max is entered. Okay, then at the same time C minus B you have, so there are two undefined symbols, ampersand 2, and this expression is entered, and a forward and a depending list is entered, indicating indicating that this max is, yeah, this is same, max is required in H. And at the same time these forward references entries are also made here. You can see that is C and B. Okay, here C, this star is made, indicating that they are undefined, and forward reference depending list is maintained, indicating that max requires C and B. Max requires C and B. Okay, now we will move to the next line. Next line is BRESW 1, and at this line this value is given. So when it finds this line, it is already entered into the symbol table. The changes are made here. What changes? See, B was a star, now it will be made as 1033, and this depending list is checked. It sees that max requires, so goes to this max entry, and it has one more unresolved symbol, that is a B. so it was ampersand 2, now it becomes ampersand 1. Okay, so this is what is done when it finds this line B. Continuing with the next line, this line. So at this line, the location counter value will be 1036. Why it is 1036? B is reserved one word. So location counter value is incremented by 3. So C will have a value 1036. So that is entered now. So this in this table, this C star is now changed with 1036. Okay, star is changed to 1036. Make use of this of depending list. Go to the entry max. In the max, okay, now C is resolved. What is the value of C? 1036. B value already it was resolved, 1033. 1036 minus 1033, subtraction is carried out and it will be 3. Okay, and at the same time use this depending list H. Go to this H and you can see that max value is known. What is the max value? That is 3. 3 plus 2, it is 5. So this is what the final symbol table where you have resolved all the forward references. So this is what you should get at the end, and this will be used by the pass. Okay, so now whatever the example I discussed, okay, it was a one of the simple example. This is textbook example. Okay, you can see all these are given and one more value is also given, that is at the line 4, at the line 4 value of the value of location counter is 1034. Okay, let us start. We'll go through this quickly. Okay, so when it finds this line, makes an entry for half z, half sz, and enters this expression, and knows, and it also enters that max len is undefined symbol. Okay, and max alien entry is made and made indicated as it is undefined because it at this line it is undefined star and depending list H half z it requires. Okay, continuing with the next line, max alien. So max alien, in the previous entry it makes a change. What is that change? It enters this expression and makes it as ampersand 2 because 2 more undefined symbols, and okay, and these undefined symbols are entered buff and buffer, indicating that these are undefined, and max len is stored in the depending list because it is needed by max len. Okay, so all these are done when this second line is processed. Continuing with the third line, in the third line we have this previous byte. In the third line we have previous byte symbol, so it is not yet entered, so it will be entered here, and it finds that it has one undefined symbol, so ampersand 1 and that expression. Okay, and no symbol that depends on previous byte, so we have null pointer. Okay, continue. Yeah, buffer. At the same time, one more change is made here with respect to this undefined symbol buffer. It maintains one more node, indicating that even previous byte requires buffer. Okay, now continuing with this next line, fourth line, and at this line 1034 is given, so buffer value is 1034. So you have now resolved the value of buffer, that is 1034, and you go back to the this previous. We have here forward this depending list, okay, containing max alien and previous byte. Okay, go to that max alien and previous byte, max len and previous byte. Use this value of buffer 1034 here. Okay, previous byte expression is buffer minus 1. Buffer value is 1034 minus 1, it will give 1033. So this change you have to do in this previous byte entry. Go to this max len entry and now resolved buffer, but you are left out with the value of buff, and so make it as &1. It was &2, now it becomes &1. Okay, now so this is the change that you will do when processing line number 4. Okay, continuing with the line number 5, buffer and EQU star. Okay, what is the value of a location counter? It will be 10. Okay, it will be that is 2034. Why it is 2034? Here at this line it was 1034. Okay, and buffer reserve byte 4096 means reserve 4096 bytes. 4096 is in decimal, and 4096 will be converted into hexadecimal. 4096 into hexadecimal, that is 1000, and 1000 you add it to 1034 and you will get 2034. So 2034 is the value of buff and it will be entered into the symbol table, and this value is used to resolve the value of max ln, and buff and max ln equation was buff and minus buffer. So how you got 1000? That is buff and 2034 minus buffer value, 1034. 2034 minus 1034, it will give you 1000. Okay, so rest of all these calculations you just verify, and so this is how you will find the values of all these forward references at the end of multiple passes of these symbol defining statements. Then it will be given to the pass 2. So this problem is one of the important problem that is oftenly asked in the question paper. So go through this problem, solve it on your own, then only you can get an idea, clear idea about this. So this is the end of this topic, that is assembler design options. Thank you.